Okay, hi guys. I think we can accelerate our course. Okay, now it's time to check the chapter number 9. Chapter number 9. And the title is Two Sample Interference. And now in the past courses, we learned one sample t-test. And now we are going to run two sample t-tests. What's the difference? What's the difference? Generally speaking, one sample test, on one hand, is called one sample. On the other hand, there is another data set. We call it population, and now we have two groups. For example, if I want to know the man's average height in Taiwan, it's impossible to select more than 10 million people to get the answer. Thus, we try to select some samples, and we select only one group of samples to interfere the whole man's height in Taiwan. And now we have different issues. There are two samples. Only consider two groups of samples. We don't consider the population. For example, the sample 1 drinking green tea, the sample 2 drinking black tea, which one can lower your cholesterol in your blood, or which one is effectively lower your blood pressure? We don't know that. And this time we can use the tool, two sample t-test. Okay, and now we have, I think we don't have enough time. Maybe we can just run one example in a test. Okay, chapter 7 discusses the method of hypothesis testing about one population perimeters. Chapter 8 discusses the method of estimating population perimeter from one sample using confidence interval. Generally speaking, we have the 95% confidence that the real population, the value or the kind of data is locating this range. This chapter will look at methods for confidence intervals and hypothesis testing for two populations. Since there are two populations, there are two random variables. Okay, there are two populations. Again, in chapter 7, one group of samples, one group of population. In this test, we discuss two populations. The same, if I say one thing, I want to know the average male's height in Korea, I mean South Korea and Japan, which is taller? Which group is taller? We don't know that. And we can know the male's height in South Korea. That is one population. And the other population is Japanese man's body height. There are two groups, and it's impossible to calculate all their heights and get the average. It's impossible. Thus, try to randomly pick up some useful information. They are called samples. And compare two groups of samples. Try to predict two populations. That's the purpose of this course. Okay. Two random variables and two means of proportions and two samples. Okay. Testing and estimating the differences in testosterone. Testosterone is a sex hormone. Okay. Levels from men before and after they had children, and testing the claim that the diet works by look at the weight before and after subjects are on the diet. I think everyone is interested about this issue, comparing before the treatment or after the treatment. They're estimating the differences in proportion of those who approve President Obama in the age group 18 to 26 years old and 50 and over the age group. Okay, and now let's check the first chapter, two proportions. Two proportions, there are times you want to test and claim about two population proportions or construct a confidence interval estimate those two different between two population proportions. As with all the hypothesis tests and confidence intervals, the process is the same through the formula and assumptions are different. Let's check it. Hypothesis test for two population proportions, two proportion tests. Okay, the first one, state the random variable and the parameters in words. X1, that the X1 to be number of successes from group 1. Why successes? Because this group, this chapter we're discussing about the proportion. Proportion, yes or no. Very easy, yes or no. And X2, the number of successes from group 2. P1, the proportion of successes in group 1. P2, the proportion of successes in group 2. So what's the proportion? The number divided by the total number is the proportion. Second, state the non-hypothesis and alternative hypothesis about the label and significance. Generally speaking, alpha, generally speaking, could be 0.05. We say that is 5%. Okay, non-hypothesis, proportion 1 is equal to proportion 2. Alternative hypothesis, they are not equal. Greater, smaller, or not equal. Okay. State and check the assumptions for a hypothesis test. First, a simple random variable size of n1 is taken from population 1, and a simple random the random sample of the group 2 is called n2 is taken from the population 2. Samples are independent. The assumption of the binomial distribution are satisfied for both populations. To determine the sample distribution P1 hat, you need to show that N1 times P1 greater or equal to 5, then N1 times Q1 greater than or equal to 5, where Q1 is 1 minus P1. Yes, I think we are familiar with the formula previously. If the requirement is true, then the sampling distribution of P1 is well approximated by a normal curve. To determine the sampling distribution P2 hat, you need to show that N2 P2 greater or equal to 5. N2 Q2 is greater than 5 or equal to 5. Then if this requirement is true, then the sampling distribution of P2 hat is well approximated by normal curve. Okay. However, you do not know the P1 and P2, so you need to use P1 hat and P2 hat. Do you need me to translate this sentence? Again, P1, P2 means the proportion from two populations, and it's very hard, it's impossible. It needs many money, many time, many labors to finish the work, but we don't have enough money, we don't have enough labor, we don't have enough time. Thus, we select fewer samples to estimate the population proportion. The selected samples and we get a proportion that is called a P2 hat, P1 hat. Okay, this is not perfect, but it is the best way you can do. Since N1 P1 hat equals N1 times X1 divided by N1, that is X1. That's X1. Okay, you need to just make sure that X1, N1 minus X1, N2 minus X1, N are all more than 5. I think it's easy. Okay, to find the sample statistics, test the statistic and p-value. sample proportion, N1, size of the sample 1, N2, size of sample 2, P1 height, that is X1 divided by N1. Again, the successes, the number of successes over or divided by the total number, that is the P1 height. The same way as the P2. The same way. Pooled sample proportion. What does it mean? Pooled. Put them together. Group them together. P bar equals in the numerator x1 plus x2. In the denominator, that is n1 plus n2. Q bar is the same as 1 minus P bar. Test statistic Z score is P1 minus P1 height minus P2 height minus P1 minus P2. Okay, then in the denominator, I know it's ugly, but we don't need to memorize the formula. We just calculate. Okay, we can check one. And confidence interval for different between two population proportions, like this one. Okay, very similar to the previous one, like this one. That's one. P1 minus P2. This range we have the 95 confidence interval that the range is between this one minus E and this one plus E. Okay, the population differences, we have the 95 confidence interval that it can be in the range this group minus E, this group plus E, where the E is E equals Z times the square root of this one. I know it's ugly, but we did calculate previously. I think we can accelerate here. Okay, maybe this one. Okay, I think I will accelerate and skip this one. Skip this one. Okay, move to the paired sample of two means. Okay, paired samples for two means. Are two populations the same? Personally, I think the chapter 9.2 is much important than previous one. So we were focusing on this one. Is the average height of a man taller than the average height of a woman? Is the mean weight less after a diet than before? Yes, great. And everyone like this one. And maybe just think a new drug, can we say that is very effective to treat heart and vascular disease? And we can say a new discovered compound or drug, can that treat the cancer? We don't know that, but we can run those kind of tests. You can compare populations by comparing their means. You take a sample from each population and compare the statistics. Anytime you compare two populations, you need to know if the samples are independent or dependent. The formulas you use are different from different types of samples. If how you choose one sample has no effect on the way you choose the other sample, those two samples, we call them independent. The way that they think about is that the independent samples, the individuals from one sample, are overall different from the individual from the other sample. This will mean that sample 1 has no effect. Oh, sorry. Can I ask a grammar question like this? Has no effect or has no effect? AFF or EFF? Personally, when I learn affect, it can be a verb, but has no, I think can be effect to be a noun. Is it a typo here? Do you agree with me? E or A? E. So you agree with me? Maybe it's a typo here. Okay. On the sample 2, the sample values from one sample are not related or paired with values from the other sample. If you choose the samples so that the measurement in one sample is paired with the measurement from the other, okay, the sample is called independent. Sorry, that is called the dependent or matched or paired. Again, previously, if I have 6 apples in my bag, if I choose one, if I choose the other one, they will not affect the second choice. They're called independent. But under some situations, if you choose one sample so that the measurement on one sample is paired with the other one, as I mentioned, if 100 people drink black tea, measured their blood pressure before and after, and this kind of sample we call it paired. Okay, let's move. Question 9.2.1, independent or dependent samples. Okay, determine if the following are dependent or independent samples. Randomly choose 5 men and 6 women and paired their heights. They should be independent since there is no reason that one value belongs to another. The individuals are not the same for both samples. Okay. Second question, choose 10 men and weight them. Give them a new wonder diet drug and later weigh them again. They have found them a special drug for their diet. Okay. Dependent, since each person's before weight can be matched with their after weight. The individuals are the same for both samples. A way to think about this is that the knowledge to the person weighs 400 pounds belongs to you something like this. Okay, before taking the medicine. Okay, so the man before had diet drug and after that they are paired. They are dependent. Okay, C. Take 10 people and measure the strength of their dominant arm, and their non-dominant arms. Okay. Dependent. Since you can match 2 arm strength, the individual are the same for both samples. So the knowledge of one person's dominant arm strength will tell you something about the strength of their non-dominant arms. Okay. Here I have I was born to be a lefty, but when I was in the kindergarten, my mother forced me to use the right hand to write. So I know this. Just a different issue. Generally speaking, in our population, human population, maybe 15% are lefty. So I think when discuss about this issue, I think about that question. Okay, then let's move to this one. Hypothesis test for 2 sample parity test. Okay, be concentrate about this issue because this one is very important. State the